Got
Hello,
it.
Dr. Cho, and welcome to Computer Science Chats. How are you?
I'm doing well. Thanks for the invitation. And how are you doing, Victor, yourself?
I'm doing great, thank you. So I prepared several questions to ask you. So first, could you please
Mhm.
introduce yourself and your educational background?
Yes, I'm Kyunghyun Cho. So I'm an associate professor of computer science and data science at New York University, jointly appointed at the Koran Institute of Mathematical Sciences and also Center for Data Science. I'm also a senior director of frontier research at Genentech, which is a Roche company. So I now have two hats to wear, which sometimes can be a bit heavy, but I'm hanging here. So my educational background. I was born and raised in Korea, and I studied there all the way until I finished my undergraduate computer science degree at KAIST. After that, I moved to Finland, Helsinki, in order to pursue the master's and PhD degrees in computer and information science. And it is there in the Aalto University where I started to get interested in and also started to work in machine learning as well as its applications to various different data types such as natural language and also biological sequences as well. After obtaining my PhD degree from Aalto University in Finland, I moved to Canada. I moved to Montreal in Quebec to become a postdoctoral scholar at the University of Montreal in a lab that is still being led by Professor Yashua Benjo, who is one of the Turing Award winners, which is one of the most prestigious, the award in the field of computer science. So I spent about approximately 2 years in Montreal, after which I joined NYU, and that's when I moved to New York City.
Thank you. So what is it that inspired you to pursue computing and data science?
Yeah, I mean, that's a big question. I mean, there were a number of, let's say, motivating, let's say, moments throughout my whole career as well as whole my educational path. But perhaps one thing that made me really interested in this data science or machine learning or artificial intelligence was was the realization that I actually don't know how to solve many problems myself. So when you think about what computer science is or the mathematics is, generally, it's all about problem solving. So here's a problem that we want to solve more quickly or more accurately or more efficiently. Then we look at the problem very, very carefully. We think about it carefully, and then we start writing what we call algorithm. The algorithm can be as simple as simple equation or as simple as opening up a Google spreadsheet and then trying to write down some of these equations and drag and drop. Or it can be as complicated as building up a new operating systems and building up a new app and everything. However, that's what we know how to do, right? That's what we do in order to solve a problem better. But then it turned out that there are many problems that we don't know how to solve. It's a really surprising thing. And then many of those problems that we don't know how to solve or we don't know how to write an algorithm to solve turned out to be those problems that we know actually we solve effortlessly, or we at least can solve ourselves. We don't know how to solve them, but we know how to solve. So what would be such an example? Driving is one example. Now, of course, the high school students don't tend to drive too much, but we're in US, so as soon as you're 16, you can get a learner's permit. But anyway, so driving, you pick any person in the world who has never driven ever. We give the instruction on driving for about 14 to 20 hours. That person will be able to drive in New York City without an issue. That easy. We can do it. Everyone can do it. Not everyone does it, but everyone can do it. But if anybody asks you or they ask me how to write an algorithm to drive a car, then no one can. It turned out that no one, literally no one can do that. Similar thing with the language. So we are having a conversation and we are having this conversation pretty much effortlessly. I know how to answer the question you asked. And for that one, I didn't have to think about how to parse this question, how to figure out what each of the words means, and then how those composition of the words means and whatnot. I didn't think about it. It was effortless. But if I have to write a question answering system, So the algorithm for question answering system, I don't know how to do that. So it turned out that there are many such problems that we want to solve, but we don't know how to solve, but somehow we know that they are solvable. And to do and compare traditional, let's say, computer science or the traditional, let's say, approaches from engineering or science weren't able to tell me what is the right way to approach this problem. There is a reason why I started to get excited about and interested in artificial intelligence as well as the data science, because this is the field where we're trying to come up with an algorithm that is going to come up with its own algorithm to solve a problem that we don't know how to write an algorithm for. How fascinating, right? Yeah.
Yeah, thank you. That's very interesting. Could you describe some of the activities that you do through your work?
Yeah, wow, okay. I mean, a lot. So that's going to be the shortest answer, but I can give you a few of them as some kind of samplers. So one is that, of course, I'm a professor. I teach. I teach data science to students at NYU, but also I do give, let's say, remote lectures or the invited lectures to the students all over the world. I teach, for instance, at the African, let's say, so African Master's Program in Machine Intelligence. So that is a 1 year long master's program in data science in Africa. And then I go there, or either I go there or I teach remotely. So the teaching is one of the main activities that I do as a professor. But of course, the second thing that I spend perhaps even more time than teaching itself is research. Because at the end of the day, what is really fascinating about science, and then the reason why we call it data science, is the fact that there are much more things that we don't know than we know. And what we need to do is to constantly look for answers to the questions that we don't know. And interestingly so, trying to figure out what are the questions that we need to answer is also something that we don't know. So, I spend a lot of time thinking about what are the things that we don't know that we need to figure out an answer to. And then once the question is there, I try to spend time working together with my graduate students as well as just myself in order to answer those unknown questions. And then once the answers are found, I try to write academic papers and then present them at conferences as well as publish them at journals. So that's the second thing. Now, the third thing I do, because nowadays I work at Genentech as well, and Genentech is one of the most science-driven pharmaceutical or the drug discovery companies in the world. There, what I'm trying to do is to see whether these recent advances in data science as well as machine learning and artificial intelligence can also advance our knowledge of drug discovery process and also to speed up the whole process of drug discovery and then thereby helping the humanity. That's a hope. I mean, we'll see whether that's going to happen, but there is a hope. So those are three main activities beside, just running on the street, once a while because, I get frustrated from not making any progress scientifically and so on, but all good, yes.
Yeah, what do you like most and what do you find most challenging about these activities?
Right. So it's a really one way to think of what scientists do, well, good scientists, right? Not every scientist, but what good scientists do is to identify and stay at the boundary between what is known and what is unknown, right? So we have to stay on that boundary. And then what we do is to try to push the boundary little by little so that what is known grows and then what is unknown shrinks. Unfortunate thing is, as you can imagine, what is known is so much smaller than what is unknown. And it's very easy to get lost because there's no signage or anything like that that we can follow because we are at the boundary of what is known. We don't know what is the right direction to go. And then what is unknown is so vast. Then the frustration is often not figuring out what to do next. And furthermore, it's possible that after many years of pursuing what is unknown, you realize looking back that you took a wrong turn 10 years ago, 5 years ago. Then you have to trace back and then restart from there. So just being on this boundary and then trying to push this boundary further just a little by little. And it's an extremely collective effort. So what that means is that individually, what I do doesn't even look like I made a dent in this gigantic, let's say, boundary, right? So, yep, a lot of frustration. So this is a kind of frustration that every scientist feels. But at the same time, this is the kind of, let's say, point at which you feel the most excitement as well, because there's always that moment. Once a year, once 10 year, not often, but once a while, what happens is that you are the only one in this entire universe who knows about this particular thing because you just push the boundary toward what is unknown, right? And then that excitement is what drives me as well as all the other fellow scientists.
Thank you. So I know that you have done significant work in machine learning and neural networks. How does this connect to data science?
Yes. Yes, so the my specialty is in, like the studying and investigating algorithms in the field of machine learning, as well as the artificial intelligence. And what data science does is to use data as a medium via which we see the world. So let's think about the idea how Newton or Einstein were able to figure out the fundamental physical laws behind the universe. They were amazing observers of the universe. They looked at how the world works, and then they ran a lot of, let's say, mental experiments to figure out how the world would look like had the fundamental law been A, B, or C. And then they try to figure out what is the right law that actually governs the universe. For some problems, we can do that ourselves. So we can just look at the universe and then try to figure out. And some other problems, sometimes we need to create a new devices or the equipment in order to see better. So when we look at the sky, we don't see most of the stars or the most of the planets, but by building a much better telescopes that can see the spectrum, the light spectrum that is way beyond the visible range, now we can see more, for instance, right? Now then, what happens is that you can push it further and then say that what if we want to look at our society or the universe, but it's really difficult. And then there are some of the phenomena that are just so vast, both in time and space, that we cannot really observe them ourselves. Then what we can do is we can use data that has been collected or data that we collect in order to see the world through the data. And then when doing so, one thing that is clear is that when there's a lot of data or when there's a very complex data, it's not easy to see through that data to figure out what are the things that are governing the universe that created or that resulted in this data. So that's where, and this is the kind of problems that I told you earlier about, the problems that we don't know how to write algorithms for. So that's where these machine learning algorithms actually come in. So these machine learning algorithms assist us in uncovering the hidden gems or the truth behind this data that we have collected or we are collecting. So that's the connection there.
Yeah, thank you. So, as you said, sometimes the amount of data can be both like a blessing and a challenge. On one hand, if you have more data, you can make more accurate models, but having a lot of data also increases the amount of time needed computationally. How can we find a balance between these two directions?
Yeah. So let's break it down into a multiple aspects. So one thing for sure is that the having more data always helps, right? More data simply means that there are more information. So, if we could always collect data, then we should. Now, when we collect data, we have to be careful though. Why do we have to be careful about it? Is because the data that was collected without a purpose is pretty much useless. So the data has to be collected with some purpose that doesn't have to perfectly align with my own purpose of how I'm going to use this data. However, data has to be collected with some purposes that align well with my own purpose. Otherwise, the data is useless. So what that means is that often we feel like amount of the data is just an independent quantity that we want to either maximize or minimize, but that's not really true. We want to maximize the quantity of the relevant data. And then that's the one thing that we need to think of. So if we have huge amount of relevant data, that's always good. But often what happens is we work with the vast amount of data that was collected with some unknown purposes. So in that case, it may not actually matter if I have more data or not, if the original purposes did not align well with my own purpose. So that's the one thing. Now, the second thing is that let's say I have a huge amount of the relevant data. Now, can we actually uncover those, let's say, hidden patterns or the hidden governing rules behind this data is another question because a lot of data doesn't tell us how to do so. So then we have to work on many of these advanced machine learning algorithms or the AI algorithms so that we can now use this large amount of relevant data. So those are at least the two different aspects that we can think of. And what that means is that it's not really about balance, but more about what are the right things we need to do in order to collect relevant data and to uncover hidden regularities from data. So no balance. We want to maximize all of them. Yes.
Yeah, that's very interesting. Changing gears a bit, I noticed on your website that you offer pro bono work. So what stimulated your approach and how can this be implemented by other researchers?
Right. I mean, this kind of pro bono work is pretty widely practiced in, for instance, in law, as well as in many other domains. Now, the machine learning scientists have not had much of the, I don't know, similar practice so far, just because, that's not been the tradition, right? So one of the reasons why I started to do this pro bono office hour or provide a pro bono office hours was the realization that there is a huge, let's say, concentration of machine learning or the AI talents or the data science talents in a small number of, or even out, actually literally say that a handful of organizations in the world. And those handful of organizations are mostly the internet service companies or the Silicon Valley tech firms. Now, those Silicon Valley tech firms are the ones who actually lead the society in terms of innovation and technology. So perhaps it's okay. But at the same time, the problems that Silicon Valley, let's say entrepreneurs as well as the tech people are interested in and are also vested in are not representative of all the problems that we want to solve in the world. So I wanted to see if I could provide even a very small, let's say, I don't know, guidance or the feedback to the people who actually are solving problems that Silicon Valley tech firms are not necessarily solving and can still benefit from a bit of data science or a bit of AI. So that's how I started it. What has happened so far is that I actually learn more from talking with these people than I think giving anything back that is useful for them. So it's been a very humbling and learning experience. And I don't think my choice of doing this pro bono office hours was a motivation or anything like that. But since I started this, the whole, let's say, society has been evolving in a way, or the research community has evolved in a way that actually encourages people to try something similar. So there is something called Machine Learning Journal Club that people have been running in a distributed manner. And then there they have all those, let's say, office hours of the very famous and also very competent machine learning researchers. So these things are, spreading out, and I'm very glad to see the trend. Yeah.
Thank you. What advice would you have for high school students who would like to get into your field?
Yes. There are two things that are extremely important technically, right? So one is mathematics, and two is programming. Now, interesting thing is that these two look very, very different, and then somehow our society has been making a very clear distinction between these two. So the software engineering and mathematics. But at the end of the day, these two are just two different forms of the same thing, same underlying principle. That is that it's really important for people or the students to practice logical thinking. So whenever there is a problem or the question that one needs to answer, what is the right logical steps that needs to be taken in order for that student to arrive at the answer, right? This is precisely what mathematics gives us, And this is precisely what programming allows us to practice directly. So these two aspects, which are very interrelated with each other, are very important. So, and I almost feel like the all high school students should anyway just learn how to do programming and also go into mathematics, just because these two are the best ways to exercise logical thinking. Now that's on the technical side. There's one more aspect that I think the students in high school can prepare themselves for is the trying to practice imagination. I don't think imagination can be practiced, but it's really important. And when I say imagination, I'm not talking about just really random things to imagine, but more like when you see something, you want to be able to imagine consequences, long-term consequences of something that is in front of you. When you look at, let's say, your laptop, what are the long-term consequences you can imagine? When you look at your smartphone, what are the long-term consequences you can imagine? When you read some book and you look at the content of that book, what are the long-term consequences that you can imagine of people who have read that book, the same book that you have read? So this is really important because at the end of the day, as technology advances, the ways in which this technology can be used can quickly diverge away from the original intention. Sometimes these new intentions or the new ways in which this technology is used are beneficial to the humanity, but in many other cases, they can be extremely detrimental and even dangerous. Then, of course, we cannot really prevent the future. I mean, if the things are going to happen in the future, yes, things are going to happen. But at the time of developing this technology or performing science, we must be able to imagine many all possible ways going to be possible, many different ways in which this technology is going to impact the society and the humanity and also the universe in general. And then for doing so, imagination is really important. So try to imagine a lot of different things.
Yeah. Where do you think that data science is going to go in the future?
Um, I actually don't know. I actually don't know. This is a kind of question that we are not supposed to know the answer to because we are at the boundary of what's known and what's unknown. So, by definition, what where we're going to be is what is in what is a known domain. So, I don't have the answer, but in the future, I'll be able to tell you. And I'll be able to tell you that this is where we ended up. Yes. And you'll be able to tell me where you all end up. Yes.
Yeah, thank you very much for meeting with me and for being willing to do this interview.
No, of course, it was very fun. And thanks for reaching out. And I'll look forward to other interviews that you're going to have in the future as well.
Yeah, thank you.